This is a visual representation of the strength duration curve. It is the minimum combination of electrical current amplitude, i.e. the strength that runs along this axis here, and the pulse duration that runs along this axis here, and what is needed within these two variables to produce the action potential in a specific nerve. Within physical therapy, it's very important that we understand this graph, especially when doing any electrical stimulation such as the TENS unit or neuromuscular stimulation, because different intensities and times are needed to produce different types of stimulation in different nerves and different pains. Knowing this information is going to help you select the correct E-stim setting, changing the pulse duration at the bottom, lengthening the time, and changing the strength or the amplitude is going to stimulate different nerves along this graph here. To start, we first have to understand what an action potential is. This picture here is another graphic representation of what an action potential is. It is the basic unit of nerve communication. It's the rapid rise, the depolarization and fall, repolarization of voltage across the cellular membrane to initiate a response. This occurs, action potential, when the threshold has been reached. So now that we have an understanding of what the action potential is and that it is used to stimulate a nerve, we can see the relationship between strength and duration in this chart here, and that's going to help form the specific electrical stimulation result. Generally speaking, the longer the duration or the pulse duration, the lower the intensity, the strength that is needed to stimulate action potential in specific nerves. So if we read this chart going from left to right, we can see that sensory nerves require a shorter duration, pulse duration, and a lower strength to stimulate action potential here. If we move to motor nerves, we can see as we go over, it requires a slightly longer pulse duration and a slightly higher current strength to stimulate the action potential in motor nerves. Same with sharp pain, a longer duration and a higher intensity. If we move to dull pain, we can see here that it's going to take an even longer duration and a higher strength to stimulate dull pain nerves. And finally here we have denervated muscles. This requires the longest amount of time and the highest current strength to send action potential to these muscles to get a stimulation. Understanding this chart is going to help you as a physical therapist safely and effectively choose the correct settings to use when giving any type of electrical stimulation, whether it be to muscles or sensory nerves within the patient that you're treating.